Welcome, Mr. Kolazar's class. We're going to start looking at the arrangement of the periodic table today. So as we're going to look at how the periodic table is broken down into three categories: our metals, nonmetals, and metalloids, and where they're at on the periodic table. So to begin with, our metals are going to be located to the left of the stair-step line. So if you haven't drawn any of your periodic table, the colored version that we've made, this line right here that I'm highlighting out is what we know as our stair-step line. And the stair-step line is going to separate our metals, which are going to be the entire left-hand side of the periodic table, from our nonmetals, which will be on the right-hand side of the periodic table, with the middle part being our metalloids, having metal and non-metal properties touching that stair-step line. So to begin with, the metals located on the left-hand side of that stair-step line. Most of our periodic table is metals, as you can see. Our metals are all solid except for mercury, lustrous, meaning shiny, ductile, which means it can be drawn into a wire, malleable, meaning it can be hammered into thin, tiny sheets, and conductive, or conductivity, meaning it can conduct heat and electricity. And again, to the stair-step line, metals are to the left-hand side of that stair-step line, except for hydrogen. Our alkali metals are going to be known as group 1. Notice that hydrogen technically is not an alkali metal, even though it appears up there on our table. We'll talk about that later. Lithium, sodium, potassium, rubidium, cesium, francium are all our group 1 atoms, our elements. Highly reactive. They do not occur freely in nature. They want to react instantly, so anytime we'd see pure sodium or lithium or any of the group 1 alkali metals, they'd be stored under oil because they react with water and oxygen very easily. They're very soft. They can be cut with a knife. Low melting and boiling points. All of these are physical properties of the alkali metals. We'll see a video in class coming up about them. They all have one valence electron or outer electron. So their electron count, we'll talk about later on, EC, they all end with N, whatever energy level or period they're in, and S1. Cesium is the element used in the atomic clock for measuring how much 1 second actually is. The alkaline metals are going to be group 2 on the periodic table, the second column. Beryllium, magnesium, calcium, strontium, barium, and radium. The group 2 elements are reactive, not as reactive as group 1 elements, so they're not found freely in nature either. They're harder than the group 1 elements, but still relatively soft for most of them. There are a few that make precious metal or precious gemstones. They have higher melting and boiling points, so all those physical properties of our alkali metals, or alkaline earth metals. And they all have 2 valence electrons, meaning they have 2 electrons at outer energy level. So each of them end whatever energy level N, and then S2 would be the last 2 electrons in those energy levels, and we'll be looking at that when we look at blocks of the periodic table. Our transition elements on the periodic table, you can see kind of behind, outlined here, are groups 3 through 12. Iron, nickel, and cobalt are our 3 magnetic elements due to the incomplete d orbitals. Our transition elements, again, the ones we think of most often as metals, are gold, silver, copper, iron, chromium, titanium, tungsten. All of those are located in that center block on the table, known as our transition elements or transition metals. Aluminum, part of that boron family, is where CDs come from, is the shiny part on the bottom of CDs and DVDs. Lead, if you've heard of unleaded gasoline, leaded gasoline used to be used because it actually raised the amount of octane produced, but lead's harmful for the environment, so we've taken it out. Member of the nitrogen family, bismuth, is where Pepto-Bismol comes from, is the element bismuth. When we get to the inner transition elements, or the rare earth elements as they're known, these are located on the bottom of the periodic table, those last two sections on the periodic table, that little block at the bottom is where they're at. They actually fit in as a subsection in there, but we want to put them at the bottom so we don't have to have an obnoxiously long looking periodic table. Their chemical behavior due to incomplete f orbitals or partially filled f orbitals. And then we get to our element uranium here. Uranium, element 92, is the last naturally occurring element. Everything after 92, and then it picks back up here, goes all the way across to element 118 now. All of these elements are synthetic or known as man-made. So everything after uranium does not occur naturally in the universe, only synthetically created in labs. Many of these have uses. Americancium is used in smoke detectors, but many of these elements, like 114 through 118, last a matter of tenths of seconds, and so not much is done with them. But since we've created them, they existed for a moment, we have to give them props on the periodic table. Metalloids now on the periodic table. The metalloids are the ones that are actually touching our stair-step line. So our stair-step line separating our metals from non-metals as we're going are located along the stair-step line. Many of them are semiconductors. And semiconductors are very important. They have the ability to conduct electricity under certain conditions. So computers and solar panels are very useful in the metalloids or in our industries because of the metalloids and being able to control those properties. So they have properties of both metals and non-metals. We've got a couple elements, polonium and astatine. Not much is known about these two elements. They're very rarely occurring. So we just kind of leave them out because we don't have much studies or uses on the properties of them on the periodic table. Non-metals are located to the right of the stair-step line. So at our stair-step line, non-metals are going to be located to the right of it, not touching, but to the right of it. Located to the right, some are gases. Liquid for bromine is our one liquid in our non-metals. If they're solid, they're brittle, meaning they break very easily, and dull looking. They are poor conductors of heat and electricity. The halogens, group 17 on the periodic table, all of the elements in the halogen family, fluorine, chlorine, bromine, iodine, astatine, and maybe septinium, our element 117, have 7 valence electrons. So group 17 we'll talk about as we're going, 7 outer electrons. Fluorine and chlorine are gases, bromine's a liquid, iodine and astatine are solids. They're very reactive and always found as a compound or diatomic. We'll talk about diatomics later. Di meaning 2, atomic meaning atom. So fluorine, if it's found, is always pure fluorine is F2, chlorine Cl2, bromine Br2, and iodine I2. So the halogen's very reactive. Noble gases, just the opposite. The group right next to them all have 8 outer electrons in their outer energy level, except for helium. Poor helium only has 2 electrons in its outer energy level, but it's full with 2 outer electrons instead of its 8. With noble gases, group 18, 8 outer electrons, meaning it's a full valence. That's going to be important as we're going because that causes the noble gases to be unreactive, or we'll know them to be inert. Reason they get the name noble gases, just like the nobles in the kingdom would not want to react or interact with any of the other elements, the noble gases don't react or interact with any of the other gases or elements. And then just a little extra information to add on to your colored periodic table. Our groups 13, 14, 15, and 16, sometimes known as mixed groups, contain metals, metalloids, and non-metals. They're given the name of the first element in that family. So the boron family is group 13, the carbon family 14, the nitrogen family, group 16, and the oxygen family, group 17, or 16, excuse me. Write these names above that colored periodic table that you've made. So you're going to just write up above boron family, carbon family, nitrogen family, oxygen family. We'll be discussing these in class. Safe travels.